Hey guys, it's AJ from Design the Everything. This week we're going to talk about fuel igniters. Now, if you watched last week, I talked about the design process and how I'm actually going to design this engine. Now, one of the things I said I was going to do was incremental tests. This week, I'm doing some of those incremental tests, trying to figure out how to design the fuel igniter. To ignite the fuel, I'm going to be using Nichrome wire and a 12-volt power supply. To start this project off, I bought a variety pack of Nichrome wire. It came with 6 different gauges from 22 gauge to 36 gauge, which is actually a really large variety. The vaping community has made Nichrome wire way cheaper and way more accessible than it was before. I didn't have any information on the properties of the wire that I bought. It didn't come with a data sheet or anything like that. So I started off by using my multimeter and testing the resistance of 12 inches, a foot, or if you're in metric land, that's 30 centimeters. Now I know that my power supply is 12 volts and rated to 5 amps. So whatever igniter I designed, it had to pull less than 5 amps. As a target, I chose to have 4 amps. That way I have a 25% safety margin. I recorded all of the resistances in a spreadsheet and used that spreadsheet to do some basic calculations. The spreadsheet shows me how long of a piece of Nichrome wire is required to stay underneath our 5 amps. Making these calculations were really simple. It's just using Ohm's law. Ohm's law is V equals I times R, or the voltage is equal to the current times resistance. Now we already know that the voltage our power supply operates on. If you look at it, it says right on it that it is 12 volts, 5 amps. Now when you're designing a circuit with a power supply like this, there's something you have to remember about those numbers. The voltage is something that the power supply provides. That power supply will always provide 12 volts. The amperage, however, is up to your circuit. The power supply does not provide a specific amount of current. It just has a maximum rating. So for example, you can think of it as a ladder. When you buy a ladder, you're going to buy a ladder, it'll say 12 feet, 250 pounds. That ladder will always be 12 feet tall, no matter what you do to it, but it will hold up to 250 pounds. It does not mean everything you put on the ladder is automatically 250 pounds. The amount of weight that the ladder is supporting, or the amount of current that the power supply is providing, is not up to the ladder itself or to the power supply itself. Rather, it's up to the load that is on that. If we put a load on the power supply that takes more than 5 amps, it'll burn out the power supply. Just like if you were to put more than the 250 pounds on the ladder, it would break the ladder. Power supplies push voltage, not current. Current is drawn by the circuit. So in order to keep our power supply from burning out, we need to make sure our whole circuit has enough resistance that it's not drawing more than the 4 amps. So back to Ohm's law. So we know that the voltage is equal to current times resistance. Since we know voltage and we know our target current, we can then calculate the resistance we need to keep from burning out our power supply. And that resistance is voltage divided by the current, or in this case, 12 volts divided by 4 amps, which is 3 ohms. Since we already know the resistance per foot of each wire, all we have to do now is divide the resistance we are aiming for by the resistance per foot that we measured, and that is how many feet the wire is. So in short, to get the length of each wire, all you have to do is take the voltage divided by the current, which is the resistance, and then divide that by the resistance per foot, and that gives us the length of each wire we need. Now I did this in feet, but you can do this in any unit. In my spreadsheet, I've done it in centimeters as well, for those of you that would rather work in centimeters. Now out of my wires, I only selected the ones that needed less than 12 inches of wire to work. I figured that there just isn't going to be enough room for coils longer than 12 inches in my actual jet engine design. For example, the 22 gauge wire needs 40 inches. That's almost a meter. Actually, it's over a meter to work. With the 3 different gauges of wire I had left, 28 gauge, 30 gauge, and 36 gauge, I wrapped them around a screwdriver to make a coil, and then I used those coils to test and see if my setup would actually ignite the alcohol fumes inside a jar, just like I've been doing my previous tests. The first test I did was with the 36 gauge. The 36 gauge, which I only needed 1.5 inches of, kind of worked a little bit. The wire did get hot, but I think it actually got hot enough that it broke itself. And while it did start a little bit of a fire on the top, it didn't actually ignite all of the vapors. I think just because it wasn't hot enough long enough. It's possible that my resistance measurement per foot of that wire was incorrect. I'm going to go back later and do some more tests on that. I think even though that this test didn't work particularly well, it is still in the running. I used 3.9 inches of the 30 gauge wire to make the next coil. This coil worked significantly better. Except again, as it got hot, it either expanded due to the heat or it got softer and drooped. But either way, it hung down into the jar, completely losing its coil shape. But even with those problems, it did still ignite the alcohol much better than the 36 gauge wire, and it got us that really good like rocket reaction that we were seeing when just igniting it with a piece of paper. The last coil was made with 5.9 inches of the 28 gauge wire, and this worked flawlessly. The coils didn't droop or misshape themselves at all, and it did do a really nice job of igniting the alcohol. The only thing I noticed about this versus the slightly smaller, the 30 gauge stuff, is that it took a little bit longer to do it. If you watch the video again, you'll see the coil start to heat up and then smoke a little bit, and then it ignites the mixture. My guess is since there is more mass, it took the wire longer to heat up, and therefore longer to get to the ignition temperature of the alcohol. That might be a problem later in the actual jet engine, but I think it's something we can work around. This week, I just made all of my igniters coils, because really my goal was just to learn about the Nichrome wire, how to size it, and how to use it. Next week, I'm going to look at the different shapes that we could do of the Nichrome wire to best ignite the alcohol evenly, quickly, smoothly, whatever a jet engine will need. And I think next week will be the last incremental test that I can do without something that actually starts to look like our jet engine. So by the week after next, I'll be able to show you what this will actually look like, and I'm excited for that. But in the meantime, thank you for watching. I appreciate you taking your time to watch this whole series of videos. This is the 4th in the series. I have 3 other ones before now. Don't forget, I offer one-on-one Fusion 360 classes. I don't have a set price on those. Those are pay what you want. Anything you pay will go straight back into the channel and help my production quality and help me build cooler projects. There are also Amazon affiliate links right down below in the description. Clicking on one of those links and buying something from Amazon will give me a small percentage of that, which again I can use to help me buy equipment for the channel or help me buy tools and so forth. I'm still on my slow and steady march to production quality. I don't know if you noticed it, but I have now installed some forward-facing lights. They aren't quite as bright as I want, but I think they do help with the image. And I am working right now on a backdrop. So no more of just my white basement wall and whiteboard. I'll have a nice wood background there soon, maybe another episode or 2. This week is also my first week editing in a real video editing software, not Windows Movie Maker. I'm still learning that, so I don't know if you're actually going to notice the difference between this video and the last one, but I should be getting better as I learn the software. As always, please hit the like button, and if you have a question, leave it down in the comments below. Also, go ahead and hit that subscribe button so you can see the rest of the series as it comes out. Thank you for watching, and I'll see you next week.